Hey there again, we're going to talk about entropy and free energy. This is going to tell you if a reaction will be spontaneous or not, whether it will happen on its own. So if you have a pile of oily rags and it starts heating up and decomposing, then heat can escape and it can start a fire right away. So we want to always store oily rags and other flammable stuff in metal containers so we won't have a spontaneous chemical reaction. So this section is talking about spontaneous chemical reactions. So there's two characteristics of spontaneous reactions. Means they happen on their own, spontaneous. Spontaneous reactions occur naturally and favor the formation of products. So when you have something that's going to happen on its own, it's going to make products. It's going to go to the right side of the chemical equation. If it's non-spontaneous, you need to put energy into the system. So in photosynthesis, you have carbon dioxide, water. You have to have light energy to make this thing happen. It will not happen on its own. So that's non-spontaneous. Spontaneous reactions make a lot of products, and they release free energy. Free energy is energy that's available to do work. So work means movement. What part does entropy play? So this is another thing we haven't talked about before, entropy. Entropy is the measure of a disorder of a system. And all systems want to go to the lowest possible energies possible. So the law of disorder states that there's a natural tendency for all systems to want to move to maximum disorder or randomness. And that's going to be the lowest possible energy. And an increase in entropy favors the spontaneous, and a decrease favors the non-spontaneous. So if you're going from solid, liquid to gas, this is more random and not so orderly as this, so this has increasing entropy. If you're breaking a solid into smaller pieces, that's increasing entropy. If you are entropy tends to increase the total number of products. So on this side we have 2 molecules, and on this side we have 3. So there's increasing entropy in this direction, going towards the products. If you increase temperature, you increase entropy because these are more random. They're moving around more, so that's increasing entropy, more disorder. What two factors determine spontaneity, whether it's going to happen on its own? The size and direction of enthalpy changes. So remember, enthalpy is heat, and entropy changes. So we have to look at two things to know if something's going to happen on its own. So these are the conditions we can look at, enthalpy changes and entropy, and see if the reaction is spontaneous. So, and then I'm going to show you the math relationship. So if both things if it's exothermic and you're getting more disorder, for sure you're going to have spontaneous. Otherwise, you have to look at the math of it and see what's happening math-wise. So we're going to use this Gibbs free energy information to help us figure out if I have a spontaneous reaction. So Gibbs free energy change is the maximum amount of energy that can be coupled to another process to do useful work. And here's the formula for Gibbs free energy. This is Gibbs free energy. This is enthalpy. This is temperature, and this is change in entropy. Okay. So if we have a negative number here for our answer, we're going to have a spontaneous process. So that's what we're looking for to see if something's going to happen on its own. So here's some examples. If we both have heat release and entropy increase, then we're going to have spontaneous for sure. If we have entropy increase and heat is absorbed, the reaction can be spontaneous, depending on those numbers. If we have heat released and entropy decreased, we can have spontaneous if the numbers are favorable, if the numbers are right. And then if we have heat absorbed and entropy increases, it's going to be always non-spontaneous. And then it just depends on the value for these numbers. We're going to have non-spontaneous. But these are examples of when you could have non-spontaneous reactions, where you'd have to put energy in to make it work. So let's see how much you got out of Gibbs free energy and entropy. So what do you think about this one? So it's the availability of work energy. So what do we always have? Free energy. So spontaneous is always going to have, free energy is always going to be available for spontaneous reactions. And you might want to pause that, read through that. It's a lot of reading. Pause me. So free energy and products. So try to think about randomness and choose the right one. Decrease in randomness. So liquid freezes is going from movement to less movement as a solid. So that would be a decrease in entropy. So what is spontaneous? What would you need for that? Good. So this is all about Gibbs free energy. I don't think I'll have any math on this, but I just wanted to make sure that you see it because you might need it later on in other parts of chemistry. And I'll talk to you soon. Bye-bye.